Hello there, Mr. Sutton here, bringing you the IM3 Honors 7-8 lesson on midline and phase shifts. In this one, we will be graphing and writing equations for trig functions with these different types of shifts. And also, we're going to be modeling real-life cyclical events such as the tides, things that repeat over and over again. For your warm-up, let's let f be some function. Describe the effect of the following transformation on the graph of f. So we've got a -2 inside the function and a +7 outside. Pause the video and give it a thought. All right, let's see what we came up with. So whenever you're subtracting something inside a function, we know just from basic function movement that this is going to shift us to the right 2. And then outside the function, adding a number, this is going to shift us up 7. And it turns out that the sine and cosine functions are no different than any other function in this regard. So here are the complete sine and cosine formulas with these horizontal and vertical shifts built into them. So we can write the sine function as y equals a sine of ab times x minus h, and then plus k. And we can do the same thing with the cosine formula. So now we have an h and a k that tell us shifting in different directions. But when you're shifting a periodic function like sine or cosine, it's a little bit different than when you're shifting a normal function in some ways. So h, we call that the phase shift, because periodic functions, they repeat over and over again in different phases. So when you change the horizontal shift, you're changing which phase is going to be on the y-axis. So this is changing basically where the cycle starts, if you're looking at the y-axis. And when we shift the function vertically with this k value, we call that the midline. This is where the vertical middle of the graph is. Now the midline can be found by taking the top and the bottom of the graph, the min and the max, and averaging them together. The midline is going to be halfway between your extremes. So max plus min over 2 will be our midline formula. We're going to do some examples now to see how we can incorporate horizontal and vertical shifts into our sine and cosine equations. And again, we're starting with one of two models. You're either using sine with the x minus h and the k built into it, or cosine. And it turns out, we're going to see, this is kind of neat, you can actually use either of these for any graph that we throw at you. We'll get into that a little bit later. Let's start by finding the amplitude. Now the amplitude here, it's not as easy as just saying, how far am I from the x-axis? Because that's 4 if you're going up, but 1 if you're going down. So we really have to use that top minus bottom divided by 2 kind of formula. In other words, finding half the height. So the top is 4, the bottom is -1. For our amplitude then, we'll have 4 minus -1. That gives us a height of 5. So 5 over 2, or 2.5, is the amplitude we're going to have to use in our equation. Now for the period on this one. If we look at, let's see here, what's an easy one? Well, here's the top of the wave, and here's another top. Oh, even easier, bottom of the wave to the other bottom of the wave. That's a distance of pi, right there. So now the b value, that'll be 2 pi over our period of pi. So b value of 2. And now we get into the trickier things, the midline. The midline, again, that is the vertical middle of your graph. That's your k value. So to find that, you just need to average the top and the bottom y values together. So instead of doing 4 minus -1 over 2, we are now going to do 4 plus -1 over 2. We're averaging those numbers together. And that'll give us 3 over 2, or 1.5. And if you look here, yep, that's about 1.5 where we estimated that dashed line. And now I've saved the trickiest concept for last. These are all a little bit tricky, but the h value by far definitely gives people the most trouble. The h value basically tells you how far you shifted whatever function you're trying to use it in away from the y-axis. So if you want to use the sine function, you have to first ask yourself, okay, where does the sine function normally start, quote-unquote, on the y-axis? Well, the sine function starts at the middle going up. That's the part of the wave that's on the y-axis. So I have to locate that part on this new graph now. So middle going up, there's 2 places, here and here, where we see that. We can pick either one of them, but I'm going to pick the closest right here. The distance from the y-axis to the new middle going up part of this wave, that distance right there, which is pi over 4, that is the h value if you want to use the sine function. Now I said if you want to use the sine function. We'll go over an alternative in just a sec. But if we're using the sine function, then we can write this as y equals 5 over 2 sine of 2, b value of 2, parentheses x minus pi over 4, close parentheses, plus the k value of 3 over 2. So we said we had some options. We don't have to write the equation for this with sine anymore. We could use cosine. The only difference is if you use cosine, everything else is going to stay the same, but you're going to have a new h value because the graph of cosine normally starts at the top of the wave. So for the h value for cosine, on this graph, you need to figure out how far is it from the y-axis to the part of the wave that's the top. So that's this part right here. So our h value for cosine is going to be this distance here from the y-axis to the top of the wave, and that is a horizontal distance of pi over 2. So now we're just going to plug all this in again, but with a different h value. We're still going to have the amplitude of 5 over 2, b value of 2, but now we're going to have x minus pi over 2, and then plus 3 over 2 at the end. So you can actually write an infinite number of functions for one graph just based on what your h value is. We didn't have to use, for example, pi over 2 for cosine. We could have used the other top of the wave, 3 pi over 2, and we could keep going as far as we wanted to. For this next equation writing problem, we're going to do a real-life application. So the Bay of Fundy has the highest tides in the world, ranging from 2 feet deep at low tide, and here's kind of a low tide picture, to 58 feet deep at high tide. And I'm not really sure if this is high tide, but it's pretty close. You can see the water comes up a little higher there if you look at the water line. So these tides are very regular, but they don't quite line up with the 24-hour day. So high and low tide are going to change every day. It's not going to be 7 o'clock every day. So let's say you and some friends observe the water level for half a day and create the following graph. So it starts off at 2 feet and fluctuates throughout the day like so. What equation can we use to tell you W of t, the water level, t hours from now? Might be useful to know if you're going out fishing whether you're at low tide or high tide, right? So here's the official problem. Try to get an equation for this graph here. Pause the video and try it. All right, so let's see what we got. Amplitude, we'll start with that one. That's half the height. So we need half of 58 minus 2, which comes out to 56 over 2, or 28. So this thing is fluctuating 28 feet from the middle value. Now let's find out the period. Our period here, from the base to the base or top to top, either way, it's 6.2. So then the b value that we need for our equation, that's going to be 2 pi over 6.2. And if we reduce that and simplify it a little bit, so you could call this pi over 3.1, but that doesn't quite seem right because we don't like decimals and fractions. So if you multiply the top and the bottom by 10, you can reduce this to 10 pi over 31. Okay, for the h value now, we have to pick the h value and the function at the same time. So taking a look here, there's a few options. We could go with negative cosine if we start at the very bottom, and then we have an h value of 0. I felt like that was kind of cheating. You could do it, but I decided to go with cosine so that I can use the top of my wave here, which I can very clearly see lines up with an h value of 3.1. So I'll go with my cosine function, h of 3.1, because that's the top of the wave here that cosine likes to start at. Sine would be much tougher on this one. You could use sine if you could find middle going up. That would be exactly halfway between 0 and 3.1, but it's a little tougher to do than just picking this value. Let's get the k value now. That's going to be the average of the top and the bottom, so 58 plus 2 over 2. That's 60 over 2, or 30. Plugging it all in now, we have 28 cosine of 10 pi over 31, parentheses x minus 3.1 plus 30. And you'll notice here that just to be consistent with what they gave me for a function, I'm saying w of t and using t as my input variable. At this point, we're going to talk about graphing trig functions that have vertical and horizontal shifts in them. For this one, I'm going to use a strategy called move the box. So we can think of the first period of sine or cosine as being inside a box, like so, that goes from 0 to 2 pi horizontally and -1 to +1 vertically. So on the left we've got 0, on the right we've got 2 pi, down below we've got -1, up above that line is +1. All I'm going to do when I regraph these things is I'm just going to shift this box over it and just change the boundaries of the box. Otherwise, I'm going to draw the function exactly the way I've been drawing it before. So this process, we're going to start by picking out the amplitude period, which is going to again be 2 pi over the b value, and then h and k from the equation. So we always have to find these 5 letters here. For my second step, I'm going to move the box, or at least note the new function bounds. So for the horizontal, that's going to be from h to h plus p. My box is going to start, my period of my function is going to start at whatever the h value is. And to get to the end of my period, well, I just have to add my period to h. So h plus p over here. Now how about the bottom and the top of my wave? So for those, I'm going to do the midline minus the amplitude to get the bottom, because the midline's in the middle and the amplitude tells you how far you have to go from the middle to get to the top or the bottom. To get the top, then I have to do the midline k plus the amplitude a. And then I'm just going to redraw the function using my 5 different points inside the box. So if I have a sine function, I start at my new midline and then I go up, down, down, up, and call it a day. So we'll do this first example together. First, we're going to start by picking out all those different letters. So actually pause the video and find all the different letters that we always find on these problems. All right, so for A, we've got 6. We have a B value of pi over 4, which means my period is 2 pi over that. So 2 pi over 4 now gives me, let's see, multiply by the reciprocal, we've got 8, because the pi's cancel. And then h value of -2, it's always opposite of what you see in there. And then a k value of -3. Now I'm going to figure out horizontally and vertically where my new function is going from. So we started off, sine by itself just goes from 0 to 2 pi for the first period, but now we're starting at -2 for the h value, and then we're going from h to h plus p, so we're going to go from -2 to whatever -2 plus the period 8 is. In this case, that would be from -2 to 6. So when I redraw my function, I'm going from -2 to 6 horizontally. I'll need to make sure I make grid lines that go from those different places. Let's talk about the vertical now. We said that was from the midline minus the amplitude to the midline plus the amplitude. We have a midline that we wrote out of -3, so I'm going from -3 minus 6 to -3 plus 6. So from -9 to +3. So let me draw some grid lines now. I'm going from -2 to +6, so I'll make sure my grid lines can go by those. And I'll also make sure that I've got a scale that allows me to chop this up into 4 different chunks here, horizontally. Now for my vertical, I'm going from -9 to +3 up here. So again, make sure you have the grid lines that allow you to do that easily. And also make sure one of your grid lines is the midline, right? Nice little rhyme there. We should have a midline of -3, so make sure you can draw that. All right, let's draw the function here. And it's up to you whether you actually draw a box. I'll draw it out real quick just to show you. So there's my little hand-drawn box going from -2 to +6 horizontally and -9 to +3 vertically. Now you might also find it helpful to draw the midline, so I'll draw that in there real quick. There we go. And now let's look at my function here. This was the sine function. That starts in the middle going up. So on the far left, I'm going to start in the middle, the midline, so right here. And then we're going up, down to the midline again, down to the bottom of the box, and bounce back up. And then draw the curve. And there we are. Here's an example for you to try out on your own now. Pause the video and give it a shot. All right, so we'll start by picking out our letters. We've got an A value of 20. Period is going to be 2 pi over 7 over 2. multiplying by the reciprocal 2/7, that's going to be 4 pi over 7. Next, for my h value, I've got positive pi over 7 and k value of 10. Now let's figure out where the horizontal is going to be. So we're going from the h value of pi over 7, and then h plus p is going to be pi over 7 plus 4 pi over 7. So bad news fractions, good news, we have a common denominator already. So we're going from pi over 7 to 5 pi over 7 if we add those. Vertically, I'm going from k minus a, which is negative 10, to k plus a, 10 plus 20, which is 30. Let me set up my grid lines so I can fit all that on there. So horizontally, I'm actually going to make 5 grid lines here because I have to get to 5 pi over 7, and my grid lines need to go evenly, need to go by the same increments. So I'll make this first one pi over 7, and then this last one will be 5 pi over 7, and they can fill in the gaps on their own if they want. And now vertically, I'm going from negative 10 down here to positive 30 up here. So these are going by tens then. Okay, let's figure out now where to put our first dot. So this is cosine. We're going to start at the top of the wave, and the top of the wave at the h value. So we're over here at pi over 7. This is our new starting place. And here's the top of the wave up here at positive 30. So here's our first dot. Then we come down to that midline at 10, down to the bottom at negative 10, bounce back up, and up to the top. Draw that cosine function in there, and call it a day. Now, I know it seems kind of weird for this thing to be kind of floating in space and not touching the y-axis anywhere, but for these, the convention, at least on my homework, is just draw one period of it. If you wanted, of course, you could keep going in the other direction and fill in the rest. This goes forever, but you got to stop somewhere, right? And we're going to stop now. Until next time, this is Mr. Sutton, signing off.